In this question, we see an inclined plane. There's a block at the top. There's a distance, an angle, and a height. So whenever we see a situation like this, we should be thinking about the block moving from the top to the bottom, in which case we have a change in height, and we have a change in speed, so we should be thinking gravitational potential energy becoming kinetic energy. That should be generally what we're thinking just from seeing that picture. So we say it's of course, initially at rest. It's at a height h, distance L, coefficient of kinetic friction. So there is friction. What is the kinetic energy of the box at the bottom of the ramp? So what we know is the total energy of a system, because of the law of conservation of energy, remains constant. So the initial energy of a system will equal the final energy of the system. And in the beginning, all we have is the gravitational potential energy. But afterward, what we have, as it's moving down the inclined plane, is we have gravitational potential energy, and we have kinetic energy, and we have work done against friction. Now at the top, at a height h, EPG, 0, is EPG, and the kinetic energy is 0, and no work has been done against friction. At the bottom, that initial gravitational potential energy is mgh. There is, at the bottom now, there is no gravitational potential energy. There is some kinetic energy, and there is some work done against friction. So we want to know the kinetic energy at the bottom of the ramp. Well, the kinetic energy at the bottom of the ramp is going to be the gravitational potential at the beginning minus the work done against friction. So that's mgh, and the work done against friction is going to be a force times a distance. And that distance is going to be L, because friction will be doing work against the object the entire time. So we're looking at some term that's going to look like mgh minus FL. So we know for sure, since some is lost, it can't possibly be that. We're not looking at two terms here, so that doesn't look right. And now here we have mgh, which is the gravitational potential energy, minus some, and we have the L in there. And this last term is mgl. Well, potential energy isn't mgl, it's mgh, so that one's out. And that leaves us with choice C. We could go through the time of deriving this equation, but we don't actually need to. We just need to understand the structure of the formula.